Welcome to Milak Online Tutorial. Now before us is this binomial theory question, and it says determine the coefficient of x squared in the expansion of y plus 3x all raised to the power of what? 6. Now, since this question is under binomial theory and the degree of our expression here now is greater than 2, okay, because at least with 2 we should be able to expand it. Okay, now but in the case of 6 here now, which is a higher degree, now we're making use of the binomial theory general formula. And what does the binomial theory general formula say? Now it says n combination r, okay, and in a case whereby the terms are, let's say, a and b, so here you have a raised to the power of r, then b raised to the power of n minus what? R. Now this is in a case whereby the expression is a plus b all raised to the power of what? N. Okay, now where our n here is the degree of the expression, okay, and our y now could be either of these, so, and our x, 3x also could be either of these depending on our r, and our r here is the degree of the term we're actually looking for. Okay, now since our x in this expression must be in the degree of 2, now it implies that, and our r here is the degree of the term in which we are looking for. So it means that 3x will be a here, and our b will be what? Y. Okay, while our r here is 2, and our n here is the degree of the question. Okay, so from here, let's come over here that y plus 3x all raised to the power of what? 6. Okay, now bringing this general formula here, we have n combination r, then ar, then b raised to the power of what? N minus what? R. So our n here is our 6, so here you have 6 combination, our r is the degree, okay, of the term we're looking for, which is 2. Then our a here, now because it's having a degree of the r, okay, which is supposed to be 2, which means our x here is meant to be in the degree of what? 2. So it means you are going to make our a here will not be 3x. You have 3x all raised to the power of 2. Then our b will not be our what? Our y. Then our n is 6. Then minus r, which is what? 2. Okay. Now this is 6 combination what? 2. And the formula for combination, I guess it should be n combination r should be n factorial all over n minus r factorial, then r factorial. Okay, all right. So, and for us to, in terms of factorial, if you have 3 factorial, it means 3 times 2 times 1. You have 4 factorial, it implies 4 times 3 times 2 times 1, and so there. Okay, here now 6 combination 2, so it implies here that if we say 6 combination 2, now this will give us 6 factorial all over, now n minus r, that will be n minus 4, will give us what? 4 factorial, then 2 factorial. Okay, now since we have 4 factorial here, we can actually simplify 6 factorial for us to get 4 factorial. And how? Since 6 factorial implies 6 times 5 times 4. Now we've gotten to 4, we should just stop because we have 4 factorial as the one of the terms in the denominator. So we can now eliminate this. Okay, and 2 factorial is something as 2 times 1. Okay, so 2 times 1 is now 2. Then since it is 2, then 2 we can now say, let me just put it as 2 times 1. Okay, so 2 here, 1, then 2 in 6, that will be 3. So we are left with what? 15, which means the whole of 6 combination 2 is what? 15. So here we have 15, then times. Now if you expand this, if you distribute 2 to the 2 terms in the parentheses, it means 3 raised to the power of 2 will give us what? 9. Then x raised to the power of 2 will give us what? X raised to the power of what? 2. So we are now with y. Then 6 minus 4, 2, that will give us what? 4. Okay, so 15 times 9 here should give us 135. Yeah, 135. Then x squared y raised to the power of what? 4. Now we're taking we are told to determine the coefficient. So the coefficient now are those terms except x raised to the power of what? 2. So in this case now we now have 1, 3, 5. If I'm to rearrange it, so the coefficient of x squared now will now be, this will now be equals to, the coefficient will now be what? 135 y raised to the power of what? 4. Thank you and God bless you.